Now the question says, find the equation of the tangent line to the graph of the given function at a specific point. So the function is a quadratic function. Now suppose your quadratic function looks like this. We're trying to, let's say, draw a tangent line at some point on the parabola, and that point is 2, negative 5. Now the equation of a line is equal to y minus y1 equals m times x minus x1, where x1, y1 is a point on the straight line. So remember that tangent line is drawn at 2, 5. So that's a point on the tangent line, and it's a point on the parabola as well, because the tangent line touches the parabola at 2, negative 5. So this is 2, negative 5. So y minus y1 is equal to, so this is y1, m, which is the slope, x minus x1. So the only thing left now is to find the slope of the tangent line. So the slope of the tangent line to any curve is equal to the derivative of the graph at that particular point. So at 2, negative 5. So remember, this is the definition of the derivative. Derivative is the same as the slope of the tangent line. So now we need to find the derivative of the function f of x equals x squared minus 9. So since we are still in section 4.1, we need to use the limit definition of the derivative, which is limit as h approaches 0, f of x plus h minus f of x divided by h. So this is the slope of the tangent line. That's equal to the limit as h approaches 0. Now we need to plug in f of x plus h. Now f of x is x the whole squared minus 9. If I replace x with x plus h, that's exactly what I do in the equation. Everywhere I see an x, I replace it with x plus h. So now we have x plus h the whole squared minus 9 minus f of x, which is x squared minus 9 divided by h. So this is equal to the limit as h approaches 0, x squared plus 2xh plus h squared minus 9 minus x squared plus 9. We're just simplifying over h. This is equal to the limit as h approaches 0, two xh plus h squared divided by h. This is equal to the limit as h approaches 0. Remember, if I substitute the limit, you get a 0 over 0. So I factor the h out. So that's 2x plus h divided by h. Cancel the common factor, which is h. Remember, h is the one that's causing the 0 in the numerator and the denominator, and that's equal to 2x plus 0, and that's equal to 2x. So this 2x is the derivative of the function x squared minus 9 at any x. It's like a function that defines the slope of the tangent line drawn to the function f of x equals x squared minus 9. But I want to draw the tangent line at a specific point, 2, negative 5. So the value of x is 2, and that's exactly where I want to draw the tangent line. So f prime of 2 is equal to 2 times 2, which is equal to 4. So the derivative of the function at 2 is equal to 4, which is the same as saying slope of the tangent line drawn at the point 2 comma negative 5 is equal to 4. Now I go back. Remember, we wrote down the equation of the line. Now we can complete that. So y plus 5 is equal to the slope that we just found out is 4 times x minus 2. This is the equation of the tangent line drawn to the function f of x equals x squared minus 9 at the point 2 comma negative 5. So this is the point slope form. If you want to simplify it, it can be written as y plus 5 is equal to 4x minus 8. Y plus 5 is equal to, y equal to 4x minus 8 minus 5. So y equals 4x minus 13. So that is the slope, or rather the equation of the tangent line drawn to the given parabola at a specific point.